Now we start the example number 13 in the question number 3 of exercise 1.1, which is the part of derivative of composite function. Again, example number 13, and after these examples is depend on logarithm. Already we study about logarithm in session number 2. We know the rules of logarithm. Here the given function y is equals to log of tan cube x into sin raised to the power 4x into x raised to the power 2 plus 7 whole raised to the power 7. Here we find the derivative of these given functions, means we find derivative of the y dy upon dx. If we have to find the derivative of given function, then we first apply the rules of logarithm here. We know that if two functions are in multiple form and is in logarithm, if two functions m and n are multiple form, then we can write log of m into n is equals to log m plus log n. Here tan cube x is one function, sin raised to the power 4x is second function, and x square plus 7 whole raised to the power 7 is another third function. If we take here three functions log of m, n, w, then we can write it log m plus log n plus log w. By using this rule, we can write it log of tan cube x plus log of sin raised to the power 4x plus log of x square plus 7 whole raised to the power 7. This function also we can write log of tan x whole bracket cube plus log of sin x whole raised to the power 4 plus log of x square plus 7 whole raised to the power 7. If we apply the rules of logarithm, which is log of m raised to the power n, we can write it n log of m. By applying this rule, whole three terms, we can write first term 3 log of tan x. Again, second term 4 log of sin x. Again, third term 7 log of x square plus 7. Now we differentiate the given function with respect to x, we get dy upon dx. 3 is constant. The derivative of log of tan x is 1 upon tan x into derivative again tan x plus 4 is constant. Derivative of log of 1 upon sin x is 1 upon sin x into again a derivative of sin x plus 7 is constant function, and the derivative of log of x square plus 7 is 1 upon x square plus 7 into again a derivative of x square plus 7. Hence, we can take a separate derivative of all these three functions. By using the derivative of log of fx, we can write derivative of log of fx is equals to 1 upon fx into derivative of fx again. Hence, we can write 3 into derivative of tan x is sec square x upon tan x, or we can write it 3 upon derivative of tan x is sec square x plus 4 into 1 upon sin x into derivative of sin x into cos x plus 7 into 1 7 upon x square plus 7 into derivative of x square is 2x plus derivative of 7, which is constant function, is 0. After that, we can write 3 into 1 upon tan x means cot x plus 4 into sin x upon cos x means 1 upon tan x means cot x sec square x as it is plus 4 into 1 sin cos x into 1 is cos x upon sin x is again cot x, plus 7 into 2 is 14 x upon x square plus 7, which is the required derivative of the given first function dy upon dx. The function is log of tan cube x into sin raised to the power 4x into x square plus 7 whole raised to the power 7. In next example number 13, given that y is equals to log of under root of 1 minus cos 3x upon 1 plus cos 3x. Here we can solve using under root x under root whole raised to the power 1 by 2. By applying logarithmic rule we can solve it, but here we solve by using the rules of 1 minus cos theta and 1 plus cos theta. We know that the 1 minus cos theta is 2 sin square theta by 2 and 1 plus cos theta is 2 cos square theta by 2. If we write 1 minus cos theta is 2 sin square theta by 2, then we can write 1 minus cos 3x is 2 sin square 3x by 2. And if we write 1 plus cos theta is equal to 2 cos square theta by 2, then here we can write 1 plus cos 3x is 2 cos square 3x by 2. Here 2 is cancelled. We know that sin upon cos is tan. Hence we can write it sin square upon cos square is tan square 3x upon 2. Here under root and square is also cancelled. Then we can write it log of tan of 3x upon 2, which is the value of y. If we differentiate this value of y with respect to x, we can write the derivative of y is dy by dx. We know that the derivative of log x, here we apply the derivative of log of f of x. And derivative of log of f of x is 1 upon f of x into again derivative of f of x. Hence we can write here the derivative of log of tan of 3x by 2 is 1 upon tan of 3x by 2 into again the derivative of tan of 3x by 2 into again the derivative of tan of 3x by 2. Here 1 upon tan means cot is equals to cot of 3x by 2. The derivative of tan of 3x by 2 is sec square 3x by 2, and we take again the derivative of 3x by 2 by using chain rule. Here cot x means cos of 3x by 2 upon sin of 3x by 2 into sec square means 1 upon cos square 3x by 2 into 3 by 2 is constant and the derivative of x is 1. Here cos of 3x by 2 and cos square is cancelled. We can write it 1 upon sin of 3x by 2 into cos of 3x by 2. These two we can write before the whole functions, and after that 3 into 1 is 3. We know that 2 sin theta into cos theta is sin 2 theta. Hence we can write 2 sin of 3x by 2 into cos of 3x by 2 is sin of 2 times 3x by 2. If we cancel 2, then we can write 3 upon sin of 3x. We know that very well 1 upon sin x is cosec x. Hence we can write it 1 upon sin 3x is cosec of 3x, which is the required derivative of dy upon dx. By using the same rule of example number 14, we can solve it y is equals to, example number 13, we can solve it y is equals to log of under root of 1 plus cos of 5x by 2 upon 1 minus cos of 5x upon 2. Here we know that 1 plus cos theta is equals to 2 cos square theta by 2. And 1 minus cos theta is equals to 2 sin square theta by 2. If the value of 1 plus cos theta is 2 cos square theta by 2, then we can write the value of 1 plus cos of 5x by 2 is 2 cos square 5x upon half of 5 by 2 means is half 5 by 4. Again we can write the value of 1 minus cos theta is 2 sin square theta, 2 sin square of theta by 2. Hence we can write the value of 1 minus cos of 5x by 2 is 2 sin square 5x upon 4. After that, similarly here 2 is cancelled. We know that cos upon sin is cot. Hence we can write it cos square upon sin square is cot square 5x upon 4. Square and square root is cancelled. Hence we can write again it log of cot of 5x upon 4. After differentiate the given function with respect to x, we can write the value of dy. Y is dy by dx. Derivative of y is dy by dx. Again we know that the derivative of log x is 1 by x. Derivative of log of f of x is 1 upon fx into again derivative of fx. Hence we can apply here the derivative of log of cot of 5x upon 4 is 1 upon cot of 5x upon 4. And we take again a derivative of cot of 5x upon 4. 1 upon cot means tan. Hence we can write it tan of 5x upon 4. Again we take the derivative of cot means minus cosec square. Hence the function 5x upon 4 as it is by using the chain rule we can take again a derivative of 5x upon 4. After that minus tan into cosec square is minus tan of 5x upon 4 into cosec square 5x upon 4 and the derivative of 5x by 4 is 5 upon 4. Here 1 upon tan means minus sin of 5x upon 4 upon cos of 5x upon 4. After that cosec square means 1 upon cos square 5x upon 4. Sorry, 1 upon sin square 5x upon 4 into 5 upon 4. If sin of 5x by 4 and its square is cancelled, then we can write minus 1 upon cos of 5x upon 4 into 1 upon sin of 5x upon 4 into 5 upon 4. 5 into 1 into minus 1, we can write minus 5 upon this 4, we can write 2 into 2 sin of 5x by 4 into cos of 5x by 4. We know that 2 sin theta into cos theta is sin 2 theta. Hence we can write 2 sin of 5x by 4 into cos of 5x by 4 is sin 2 into 5x upon 4. Here 2 and is 2. We can write it minus 5 into 1 upon sin of 5x upon 2. And we know that 1 upon sin is cosec. Hence we can write it minus 5 cosec of 5x upon 2, which is the required derivative of the given functions. Next one is example number 15. Y is equals to log of under root of 1 minus sin x upon 1 plus sin x. If we solve this example, then we know first quadrant rules. The first quadrant rule is sin of pi by 2 minus x is equals to cos x and cos of pi by 2 minus x is equals to sin x. Here if we convert this sin x into cos, then we can write sin x is equals to again cos of pi by 2 minus x. First we simplify the logarithmic function. In bracket under root of 1 minus sin x, we convert sin x into cos of pi by 2 minus x upon 1 plus sin x is again cos of pi by 2 minus x. Now we can apply similar form of 1 minus cos theta is equals to 2 sin square theta by 2 and 1 plus cos theta is equals to 2 cos square theta by 2. By using this rule, we can solve this example. 1 minus cos of pi by 2 minus x is 2 sin square. Half of pi by 2 is pi by 4 and half of x is x by 2 upon here 2 cos square. Half of pi by 2 is pi by 4 and half of x is x by 2. Here again 2 cancels. We can write it log of sin upon cos is tan square pi by 4 minus x by 2. Square and square root again cancel. Can we write log of tan of pi by 4 minus x by 2? After that, if we differentiate given function, we get the required derivative of y. We can write the derivative of y is dy by dx. Derivative of log x is 1 upon x. Hence we can write derivative of log x is 1 upon fx. It is tan of pi by 4 minus x by 2 into again the derivative of tan of pi by 4 minus x by 2. We know that 1 upon tan of pi by 4 minus x by 2 is cot of pi by 4 minus x by 2. Hence we can write this cot of pi by 4 minus x by 2. The derivative of tan x is sec square x. Hence we can write derivative of tan x is sec square pi by 4 minus x by 2 into again the derivative of pi by 4 minus x by 2. Hence we can write here 1 upon cot x into pi by 4 minus x by 2 is cos of pi by 4 minus x by 2 upon sin of pi by 4 minus x by 2. And again we can write 1 upon sec square means 1 upon cos square pi by 4 minus x by 2 into derivative of pi by 4 is 0 and the derivative of minus x by 2 is minus 1 by 2. We can write here minus 1 by 2. Now cos of pi by 4 minus x by 2 and square is cancelled, then we can write minus 1 upon 2 sin of pi by 4 minus x by 2 into cos of pi by 4 minus x by 2. Again we know that 2 sin theta into cos theta is sin 2 theta. Hence we can write minus 1 upon sin double of pi by 4 is pi by 2 and double of x by 2 is x. And we know that 1 upon sin is cosec. Hence we can write minus cosec of pi by 2 minus x, which is the required derivative of y dy upon dx. We can write this also. Cosec of pi by 2 minus x is minus sec of x. Hence again we can write the value, the derivative of y dy by dx is minus sec x, because by using the quadrant rule we can write cosec of pi by 2 minus x is sec x. In this example, if we apply the rules of logarithm, log of m into n, then we can write log of m into n is equals to log m plus log n. Here we consider the first term m is 4 raised to the power 2x and second term n is x square plus 5 under root 2x cube minus 4 raised to the power 3 by 2. Then we can write it log of 4 raised to the power 2x plus log of x square plus 5 upon under root of 2x cube minus 4 whole raised to the power 3 by 2. We know that log of m raised to the power n is again n log m. Hence we can write it 2x into log 4 plus 3 by 2 into log of x square plus 5 upon, we can write this under root function into 2x cube minus 4 whole raised to the power 1 by 2. Hence we can write it 2x log 4 plus 3 by 2. Here we use the rules of logarithm, which is log of m upon n. And the log of m upon n is log m minus log n. Hence we can write it log of x square plus 5 minus log of 2x cube minus 4 whole raised to the power 1 by 2. After that, if we differentiate the given function with respect to x, y derivative of y is dy by dx. 2 constant, log of 4 is constant, we can write the derivative of x plus 3 by 2, we can take a separate derivative of these both functions. We can write a derivative of log of x square plus 5 minus this function log of 2x cube minus 4 whole raised to the power 1 by 2. We can write 1 by 2 into log of 2x cube minus 4. 1 by 2 is constant function and we can take a derivative of log of 2x cube minus 4. After differentiating, again we can write the derivative of x is 1, hence 2 log 4 plus 3 by 2 as it is. We can write it the derivative of log of x square plus 5 is 1 upon x square plus 5 into again derivative of x square plus 5. The derivative of x square is 2x and the derivative of 5 is 0 minus 1 by 2 into, we can write the derivative of 2x cube minus 4 is 1 upon 2x cube minus 4 into again a derivative of 2x cube. X cube derivative is 3x square. 3 into 2 is 6x square minus derivative of 4 is 0. Hence we can write it 2 log 4 plus 3 by 2 into 2x into 1 is 2x upon x square plus 5 minus 6x square into 1 6x square upon 2 into 2x cube minus 4 or 4 into x cube minus 2, which is the required derivative of y dy upon dx. Next example, number 17 is y is equals to log of e to the power x square 5 into 5 minus 4x whole raised to the power 3 by 2 upon cube root of 7 minus 6x. We know the whole rules of logarithm. Log of m raised to the power n is equals to n log m. Log of m into n is equals to log m plus log n. Log of m upon n is equals to log m minus log n. If we apply here the rules of log of m upon n is equals to log m minus log n, then we can write it log of x e to the power x square into 5 minus 4x whole raised to the power 3 by 2 minus log of cube root of 7 minus 6x. After that, here we again the derivative log of m into n. Hence we can write log of e to the power x square plus log of 5 minus 4x whole raised to the power 3 by 2 minus log of, we can write this cube root of 7 minus 6x is 7 minus 6x whole raised to the power 1 by 3. After that, again we can apply the rules of log of m raised to the power n is n log m. Hence we can write x square log e plus 3 by 2 log of 5 minus 4x minus 1 by 3 log of 7 minus 6x. If we differentiate the given function with respect to x, then we get dy by dx. Log e is a constant function and we take a derivative of x square is 2x plus 3 by 2 is again constant function and we take the derivative of log of 1 upon 5 minus 4x is 1 upon 5 minus 4x into again derivative of 5 minus 4x. 1 minus 3 is a constant function. Log of 1 upon 7 minus 6x is 1 upon 7 minus 6x into again a derivative of 7 minus 6x. After that, the value of log e is 1. Hence we can write 1 into 2x plus 3 by 2 into 1 upon 5 minus 4x into derivative of 5 is 0 and derivative of minus 4x is minus 4. Hence we can write the direct derivative of 5 minus 4x is minus 4. Minus 1 by 3 as it is 1 upon 7 minus 6x into the derivative of 7 is 0 and minus 6x is minus 6. 0 minus 6 is minus 6. Hence we can write the direct derivative of 7 minus 6x is minus 6. 1 into 2x is 2x plus 2 is 1 and 4 is 2 minus 2 into 3 is minus 6 upon 5 minus 4x. Here 3 is 1 and 6 is 2 minus 2 into minus 1 is plus 2 upon 7 minus 6x, which is the required derivative of the given function is dy upon dx. In the example number 18, y is equals to log of a to the power cos x upon x square minus 3x whole bracket cube into log x. Here we again log of m upon n, which is log of m minus log n. After that, in denominator again we will apply log of m into n, which is log m plus log n. And after that, here the rules of log of m raised to the power n is again log of n log of f. By applying this rule, first we can write log of a to the power cos x minus log of x square minus 3 whole bracket cube into log x. Log of a raised to the power cos x as it is minus, here again we apply log m into log n, which is log of x square minus 3 bracket cube plus log of log x. If we take this both functions out of bracket, then we can write log of a to the power cos x is cos of x into log e plus minus 3 log of x square minus 3 plus minus log of log x. If we differentiate the given function with respect to x, then we can write the derivative of y is dy by dx. Log a constant function and the derivative of derivative of cos x is minus sin x. Minus 3 constant, the derivative of log of 1 of x cube minus 3 is 1 upon x cube minus 3. And we take the again a derivative of x cube minus 3, which is again a derivative of x square minus 3 minus derivative of log x is 1 upon log x, and we take the again a derivative of log x minus sin x into log a minus 3 upon x cube minus 3, and the derivative of x square is 2x minus 3 is 0 minus 1 upon log x into the derivative of log x is 1 by x. Hence we can write this minus sin x into log a minus 2 into 3 is 6x upon x cube minus 3 minus 1 upon x log x, which is a required derivative of dy upon dx. The next example, example number 19, which is in the form of 25 log base 5 resec x, 16 log base 4 tan x. If we know a to the power log base a f of x is equals to f of x, then we can convert this both function in this form. We know that 25 is the square of 5, hence we can write it 5 square and into 2 log base 5 sec x as it is, minus 16 is the square of 4, hence we can write 4 square log base 4 tan x. After that, we know that log of m raised to the power n is n log m. Hence we can write n log m is equal to log of m raised to the power n. By applying this rule, we can write it 5 raised to the power log base 5 sec square x minus 4 raised to the power log base 4 tan square x. By applying this rule, a to the power log base a f of x is equal to f of x, we can write this 5 raised to the power log base 5 sec square x is sec square x minus 4 raised to the power log base 4 tan square x is tan square x. We know that the trigonometric rules, which is identity form, sec square x minus tan square x is 1, because sec square x minus tan square x is equals to 1. After differentiate this function with respect to x, we get the derivative of y, which is dy by dx, and the 1 is constant function. We can write the derivative of 1 is 0. Hence, the derivative of 25 raised to the power log base 5 sec x minus 16 log base 4 tan x, which is dy by dx, is equals to 0. Last example number 20. In question number 3 is y is equals to x square plus 2 whole raised to the power 4 upon under root of x square minus 5. We know that derivative of u upon v is v into du upon dx minus u into dv upon dx upon v square. By applying this rule, we can write, if we differentiate with respect to x, then we can write the derivative of y dy upon dx is under root of x square minus 5 into derivative of u means x square plus 2 whole raised to the power 4 minus under root of x square plus 2 into raised to the power 4 into derivative of under root of x square minus 5 upon v square means under root of x square minus 5 whole raised to the power 2. After that, under root of x square minus 5 as it is, the derivative of x square plus 2 whole raised to the power 4 is 4 into x square plus 2 raised to the power 4 minus 1 is 3, and we take again the derivative of x square plus 2 minus x square plus 2 whole raised to the power 4 as it is, and we take the derivative of under root of x square minus 5 is 1 upon under root of 2 root x square minus 5, and we take again a derivative of x square minus 5 upon under root of x square minus 5 whole bracket square and square root cancel, x square minus 5 as it is. After that, we can write under root of x square minus 5 as it is, 4 into x square plus 2 whole bracket q as it is, the derivative of x square is 2x minus x square plus 2 whole raised to the power 4 as it is, 1 upon 2 under root of x square minus 5 as it is, and the derivative of x square is 2x upon x square minus 5 as it is. Again we can write under root of x square minus 5 as it is, 4 into 2 is 8x, x square plus 2 whole bracket cube, here 2 to cancel, minus x square plus 2 whole raised to the power 4 upon under root of into x upon under root of x square minus 5. Whole denominator x square minus 5. If we take the cross product of both terms, we can write under root of x square minus 5 into under root of x square minus 5 is x square minus 5. 8x first into x square plus 2 whole bracket cube minus 1 into this term x into x square plus 2 whole raised to the power 4 upon under root of x square minus 5, which is we can write x square minus 5 whole raised to the power 1 by 2 into x square minus 5 as it is. After that, we can write it 8x as it is into x square minus 5 into x square plus 2 whole bracket cube minus x into x square plus 2 whole raised to the power 4 upon, if the base are equal, x square minus 5 whole raised to the power 1 by 2 plus 1, which is the rules of indices, is 3 by 2, which is the required derivative of y dy upon dx. Again we can take common of these both terms x and x square plus 2 whole bracket cube. If we take x into x square plus 2 common both these terms, we can write 8 into x square minus 5 Next example, question number 4. Given that f, g, f dash and g dash as below. If the value of x is 2, then f of 2 is 1. When the value of x is 4, then f of 4 is 3. When the value of x is 6, then f of 6 is 5. Similarly, when we take the value of x is 2, then g of 2 is 6. When we take the value of x is 4, then g of 4 is 4 and g of 6 is 2. After that, f dash of x, if the value of x is 2, then f dash of 2 is minus 3, f dash of 4 is 5 and f dash of 6 is minus 4. Similarly, f dash of 2 is 4, g dash of 4 is minus 6, g dash of 6 is 7. After that, we have to find the value of r dash of 2, capital R dash of 4, s dash of 4 and s dash of 6. First we solve. Number first, if r of x is equals to f of g of x, then we have to find r dash of 2. If we have to find the solution of first example, r dash of 2, then first we take a derivative of rx. First of all, given that r of x is equals to f of g of x, if we differentiate with respect to x, then we get the derivative of rx is r dash of x. The derivative of f is f dash of g of x. It is composite function. We consider g of x, then we take the derivative of fx. Hence, we can take again the derivative of g of x. We know that the derivative of g of x is g dash of x. Hence, we can write r dash of x is equals to f dash of g of x into g dash of x. After that, for the value of x is equals to, we have to find r dash of 2. If we put the value of ix is 2, then we get r dash of 2, we replace the x by the 2, is equals to f dash of g of 2 into g dash of 2. Given that the value of g of 2 is 2, we can write f dash as it is. The value of g of 2, here g of x, the value of g of 2 is 6. We can write the value of g of, we replace x by 2, then the value of g of 2 is 6, and g dash of 2 is, g dash of 2 is 4. Now we put the value of f dash of 6. First we take the column of f dash x. We put x replaced by 6. Hence f dash of 6 is minus 4. Minus 4 into 4 is equals to minus 16, which is a required value of r dash of 2. Secondly, we have to find the value of r dash of 4. And here, given that r of x is equals to g of 3 plus f of x. If we differentiate with respect to x, then we get the derivative of rx is r dash of x is equals to the derivative of g is g dash of 3 plus fx. After that, we again differentiate 3 plus f of x. If we take the derivative of 3 plus f of x, then g dash of 3 plus f of x as it is. We know that the derivative of 3 is 0 into plus derivative of f of x is f dash of x. We have to find the value of r dash of 4. If we replace x is equals to 4, then we get r dash of 4 is equals to g dash of 3 plus f of 4 into f dash of 4 is equals to, given that f of 4 g dash of 3 plus f of 4, we have to find the value of f of 4 in the column of f of x. If the value of x is 4, then we get the value of f of 4 is 3 into f dash of 4. F dash of 4 is 5. Here we get 3 plus 3 is 6 into 5. We know that g dash of 6, g dash of 6 is equals to 7. G dash, the value of g dash of 6 is 7. 7 into 5 is equals to 35, which is the required value of r dash of 4. After that, we have to find the value of h dash of 4. And here, given that s of x is equals to f of 9 minus fx. If we differentiate with respect to x, then we get s dash of x. If we take the derivative of f of 9 minus f of x, then we get the f dash of 9 minus f of x, and we take the again a derivative of 9 minus f of x. Here f dash of 9 minus f of x as it is, and derivative of 9 is 0 minus derivative of f of x is f dash of x. After that, if we replace the value of x is 4, then we get a required answer h dash of 4. If we put in every term x replaced by 4, then we get f dash of 9 minus f of 4 into minus f dash of 4. The negative sign minus f dash of 9 minus the value of f of 4 is, f of 4 is 3 into the value of f dash of 4, f dash of 4 is 5. minus f dash of 9 minus 3 is 6 into 5. F dash, the value of f dash of 6 is minus 4 into 5 minus minus plus 4 into 5 is equals to 10 20, which is a required value of s dash of 4. After that, last one, s of x is equals to g of x. We have to find the value of h dash of 6. If we differentiate s of x with respect to x, then we get s dash of x. The derivative of gx is g dash of gx into again the derivative of g of x is equals to g dash of g of x into g dash of x. We know that the value of g of x, we have to find the value of h dash of 6. For x is equals to 6, we get the value of h dash of 6. Here g dash of g of 6 into g dash of 6. Here the value of g of 6 is 2 into g dash of 6. G dash of 6 is 7. The value of g dash of 2, g dash of 2 is 4. Means it 4 into 7 is equals to 21, which is the required value of s dash of 6, 28. In next question, question number 5, given that f dash of 3 is equals to minus 1, g dash of 2 is equals to 5, g of 2 is equals to 3, and y is equals to f of g of x, then we have to find the derivative of y with respect to x at x is equals to 2. If we have to find dy by dx at x is equals to 2, then we have to find first dy by dx. After that, if we replace the value of x is 2, then we get the required value of dy by dx at x is equals to 2. Hence, first of all, we can write given function y is equals to f of g of x. If we differentiate the given function with respect to x, then the derivative of y is dy by dx. The derivative of f is f dash of g of x, and we take the again the derivative of g of x. Here f dash of g of x as it is, and the derivative of g of x is g dash of x. Again we have to find the dy by dx at x is equals to 2. Therefore, dy upon dx at x is equals to 2 is equals to f dash of g of 2 into g dash of 2 is equals to f dash of, given that the value of g of 2 is 3, into the value of g dash of 2 is 5. Again we can write the value of f dash of 3 is minus 1 into 5 is equals to minus 5, which is the required value of dy by dx at x is equals to 2. Next, example number 6 is h of x is equals to under root of 4fx plus 3gx. Given that f of 1 is 4, g of 1 is 3, f dash of 1 is 3, g dash of 1 is 4, and we have to find the value of h dash of 1. If given that h of x, and if we have to find the value of h dash of x, then we differentiate given function. It means that the given that h of x is equals to under root of 4fx plus 3gx. If we differentiate with respect to x, then we get the derivative of hx is h dash of x. Derivative of under root is 1 upon 2 under root of 4fx plus 3gx into again a derivative of 4fx plus 3gx is equals to 1 upon 2 under root of 4fx plus 3gx as it is. We know that 4 is constant function and the derivative of fx is f dash of x, plus 3 is constant function and the derivative of g of x is g dash of x. Hence we can write it h dash of x is equals to 4f dash of x plus 3g dash of x upon 2 under root of 4fx plus 3gx. If we replace the value of x is 1, then we can write for x is equals to 1 is h dash of 1, which is required answer value, 4 into f dash of 1 plus 3 into g dash of 1 upon 2 under root of 4f of 1 plus 3g of 1. After that, we can write h dash of 1 is equals to 4 into the value of f dash of 1 is given 3. Again, plus 3 into the value of g dash of 1 is 4 upon 2 under root of 4 into the value of f of 1 is 4 plus 3 into the value of g of 1 is 3. 4 into 3 is 12 plus 12 upon 2 under root of 16 plus 9 is 24 upon 2 under root of 25. 25 whose 1 and is 24, so 12 is equals to 12 upon under root of 25 means 5, which is the required value of h dash of 1. Last example in the exercise number 1.1, question number 7. Find ex coordinate of all the points on the curve y is equals to sin 2x minus 2 sin x, and all value of x is in between 0 to 2 pi. If the given angle is 0 to 2 pi and given that dy by dx is 0. First we write given curve y is equals to sin 2x minus 2 sin x. If we differentiate with respect to x, the value of y is dy by dx, and we take again derivative both separate, 2 into derivative of sin x. Derivative of sin 2x is cos of 2x, and we take again the derivative of 2x minus 2 into derivative of sin x is cos x. Derivative of 2x is 2, hence it can write 2 cos x minus 2 cos of 2x minus 2 cos x. But by given condition dy by dx is 0, hence we can write the value of dy by dx is 0. That is, we can write also it, if we take this minus 2 cos x right side, it get become positive 2 cos x is equals to 2 cos of 2x. Here 2 to cancel, cos x is equals to cos 2x. By using this condition of cos x is equals to cos 2x, we can find the value of coordinate, which is x. If the value of x is 0, then we can say it cos 0 is equals to cos of 2 into 0 also 0. Hence, the first value of x is 0. Similarly, we can find the value of x is also 2 pi by 3. If we take the x 2 pi by 3, then we can say again cos of 2 pi by 3 is equals to cos of double of 2 pi by 3, 2 into 2 pi by 3. Hence we can say cos of 2 pi by 3 is equals to cos of 4 pi by 3. Also, we can say x replaced by 2 pi then cos of 2 pi is equals to cos of 2 into 2 pi and similar value. Hence cos of 2 pi is equals to cos of 4 pi. There hence the value of x coordinate is x is equals to 0, 2 pi by 3 and 2 pi, which is the required value of x coordinate.